Calculus, Unit 7, Day 62, Part 3. Now we are going to be given a couple different things we have to do trying to find the area between two curves. So picture to the right is the graph of f of x equals x cubed over 4 minus x squared over 3 minus x over 2 plus 3 cosine x, and a line L, which is tangent to f of x at point 0, 0.03. So I just tried to label some of this, and they're not talking about which one's the top, which one's the bottom right now, but the first thing they ask is find the area of region R. So what I'm trying to do here is I'm going to try to find, and that just is dealing with this cubic function f of x. And I should probably label that this is f of x. Okay, so I'm looking at the area of R is going to be the integral from some point, I don't know, we're going to use our calculator to figure that out in a second, all the way up to 0 of f of x dx. And actually we're going to do all of this on our calculator, but the first thing we're going to want to do is try to find out what this intersection is. Okay, so let's do that. So in my calculator I type in the function. Now let's go, and I just did a zoom standard, so I did graph and it went through, and now I'm going to go through and find that intersection of that point. So let's go and do that right now. So that's going to be second calculate. Let's calculate the 0 because I know it's on the x-axis. I'm going to go a little bit to the left, enter, a little bit to the right, enter, guess. And so this negative 1.373122, so that's going to be my integral from this point all the way up to the 0. So let's just go back and write that on in the note. So I'm just putting that right here. So now there's two ways I can do this on my calculator. Let's see if I can do it this way. So one way is to say, okay, let's calculate, second calculate, choice 7. And what's my lower limit? And I think I can type this in, let's hope so, where it's the negative 1.373122, enter, and I'm getting an error. Let's find out why. Oh, I used the wrong negative button, sorry. And I might have to do this on my calculator. I've been trying to do it on my screen here. Oh, let's try that here. So the gray negative, negative 1.373122. So again, make sure you're not using this negative over here, using the negative down the bottom, because this up here is for subtraction. Enter. Okay, what's my upper limit? That's 0. Enter. And my answer is 2.9030944, which again, 3 decimal places, which we got to get really good at as we get closer to the test. 2.903. Okay, another way to do this same thing, second quit. Let's come out here, clear everything, and I can do math, choice 9, and I know I'm going from 0 to, and excuse me, not 0. 0 is not the, let's try this again. 0 is the upper limit. Okay, so now that I have the right interval in there, negative 1.373122 to 0. My function was in y1. Remember, we do vars, y-vars, maybe y-vars. There we go. Function y1, and we just know we're taking this with respect to x, because that's what and that's most times on the calculator, that's what we're going to do. Most times, not all the time. And it gives me the same exact answer. So that's pretty good that we can do that on the calculator. All right, let's look down to the next part. And so the next one wants us to find the equation of the line L if it is tangent to the graph of f of x at 0, 3. So I now need to find out, hey, the point of tangency and the slope of tangency. Point of tangency, they gave me, hey, that's 0, 3. I'm just going to write it like this. What is the slope of tangency? Hey, that means if I can find the derivative of f and substitute in the 0, then whatever the value of the derivative at that point is going to represent the slope of the tangent line. So I can go in and take the derivative and put in 0. Um, and what would we get? We would get 3x squared over 4 minus 2x over 3 minus 1 half. And then the derivative of cosine is negative sine, so negative 3 sine x. When I put in a 0, I did not give myself enough space. 0, 0. And what I'm getting at is, so sine of 0 is 0, and so therefore this is negative 1 half. Part of what I'm doing here is I'm going to show you how we can do this on the calculator. So I can take the derivative. Remember, I can do math, choice 8, take the derivative with respect to x of vars, y vars, function y1, and I want to find out when x equals 0, and it should give me the negative 1 half. Yeah, that's, I wish it said negative 0.5, but that's pretty close. And let's see what it would look like if I did it here. So if I did second calculate choice 6, um, and now I'm at 0, 3. I think if I hit enter, it should give me the, and it's even a little bit more, but that's negative 0.5, negative 1 half. Okay, so and that's good practice too, seeing that the calculator is not always going to be exact. Let me try that again and just put in what the 0 is. So what the derivative is at x equals 0, and then hit enter. Okay, gives me the same thing on that. So a couple different ways of finding that, but it is negative 1 half. And so for the solution, we're still going to do y minus 3 equals m times x minus 0. I could leave my answer like that, or I could distribute the negative 1 half out and add 3 and get y equals negative 1 half x plus 3. Either way, sometimes it's easier to leave it like this so you don't make any mistakes. Okay? All right, let's go on to, we're calling that part 3. We'll go on to part 4.